Direct variation equations. That is the topic for this lesson. Um, we're going to review that. We did this a little bit in Algebra 1, and I just want to review with you the definition of a direct variation equation. This simply means that the y-intercept is 0. All right, and if the y-intercept equals 0, then we know that the line, when we graph it, is going to run through the origin. So it will run through the origin, which is that spot where the x and y axes come together. If we have direct variation, we call the constant on our x term, so we call our slope the constant of variation. It's just another name for slope, and we only refer to it as the constant of variation when we have a direct variation equation. So in number 1, they want you to write and graph a direct variation equation that has that given ordered pair as a solution. So one of the solutions, meaning one of the points on the line, is going to be 5, 10. And we are going to write and graph that equation. Now, if we have a direct variation, then we know our y-intercept is going to be 0. And so we don't even need to write in that b. We don't need to write in plus b. Our skeleton, our formula becomes y equals mx. If I write the b in, it's just going to zero out because direct variation means, and they've told you right here, this is going to be direct variation, means that the y-intercept is 0. So now what I can do, though, is I have a point on that line. I can calculate my slope by using that point. So I can put 10 in for y. My m is the variable that I'm going to solve for. And so I'm going to end up with 10 equals 5m and m equaling 2. So my slope is 2. My y-intercept is 0. And so my direct variation equation becomes that. Then I can go to the graph because they asked us to graph it as well. I know I've got the point 5, 10. And make sure you notice here that they're numbering by the number line by 5s. So 5, 10, and then because it's direct variation, it also is going to run through the origin. And so I can use those 2 points right there to connect. Now number 2, I'm going to do it a little bit differently. You can do it the way we did it in number 1, or you could actually just start by graphing the point that you're given. And so I'm given negative 6, 3. So I'm going to plot that, negative 6, 3. And again, they told me this is direct variation. So I can come and plot my second point at the origin because I know my y-intercept is going to be 0, which means that this is going to run through the origin. And then I can use the graph to calculate my slope, to calculate the constant of variation. And I can do that just by counting. So if I wanted to start with that top point up here, then I'm going to count down 3. So that means, remember, I'm starting with my rise first, so that's directional, that's direction up or down. In this case, I'm going down, so I'm going to put a negative sign there, and I went down 3 units. And then from this point where I went down, right here, I'm going to count to the origin. And when I do that, I go to the right, so that's positive direction, 6 units. And then, of course, I want to reduce that to negative 1/2. So now I know that my slope is negative 1/2. I know I have a direct variation equation, so I can just leave that plus b out of it. And this then is your final answer, and of course you'll connect those dots up there for the graph. On numbers 4 and 5, we're going to do the same thing. We just don't have a graph to look out. So we're going to have to do it the way we did number 1 as opposed to number 2. because I'm not going to have a graph to use to count my slope out. So they told me it's direct variation. Okay, they said the variables x and y vary directly. That's just another way of them to tell you that they want you to write a direct variation equation. So because of that, this is the only part of the formula I need. I don't need the plus b. The plus b would zero out. I'm going to use the y that they gave me and the x that they gave me. So they gave me a point on the line, they just wrote it out differently. They could very easily have just written it like they did in 1 and 2, like that. Right, when I get my slope, then I end up with a negative 4/3 after I've reduced. All right, so there's my slope. I'm going to write the equation out by putting that slope in at m. And there's my equation. Now they did ask us to continue on and find y when x is 3. So for the second part, this is a two-part question. I'm just going to evaluate at x of 3. That's really 3. You can put any number over 1. And so when we do that, I can see that this numerator cancels with that denominator, and my y is negative 4. All right, so when x equals 3, y equals negative 4, and now I have 2 points on the line. So I could graph this from those 2 points if they had asked me to. Actually, I didn't even need that second point, really. I could have graphed it from the information that we did previously. I will do the same thing on number 5. My slope will be 4. So then my equation becomes y equals 4x. And that's the first part. The second part will be what is y when x is 3. So I'm going to evaluate at x of 3, and I'll get a y of 12. And then I have a second point on that line. On 13 and 14, they want us to tell whether the equation represents direct variation. And if it does, then they say give us the constant of variation, which again is just another name in a direct variation equation. It's just referring to the slope. And so in number 13, you can see that this is direct variation because it follows the definition of having 0 as its y-intercept. And so we would say yes, this shows direct variation. The constant of variation is the slope, which is negative 3. Number 14, right now it's not in slope-intercept form, so if we put it in slope-intercept form by solving for y, now we can see even more clearly. You probably could see it in 14, originally in that original equation, that this was not going to be direct variation because you have a constant. It's not on the correct side right now, but that still is a constant that when taken to the other side will give you your y-intercept. So the y-intercept here is not 0. This follows our linear equation formula for a graph that is not going to run through the origin with a slope of negative 2. So the answer here is no. This does not show direct variation. So there's not going to be a constant of variation. Don't write no on these and then answer the constant of variation as being 8. It's not. It's just a definition, and so that definition only goes for an equation, a graph that has y-intercept of 0, and so therefore runs through that origin. Now in 19 and 20, they are asking us to look at these data tables and determine whether they show direct variation. And if they do, we need to write an equation relating x and y, which means we're going to write a direct variation equation. So if you look at that table in 19, the easiest way to determine these direct variation equations is to actually calculate the slope at each point. So what I mean by that, and really it's a ratio between the y coordinate and the x coordinate. So in order to do that, you would take your y and you would divide it by your x coordinate for each point. So for this first point here, we would say 4 divided by -2, and we're going to get -2 when we do that. All right, then we would come over here to that second point, 3 divided by -1, and we'll get -3. All right, 2 divided by 0. We know that we can't divide by 0, so this actually ends up being undefined. 1 divided by 1 is 1, and 0 divided by 2 is 0. Because all of those ratios are different, meaning all of these are calculated and they're not the same. They all need to be the same to show direct variation. So because they do not show sameness at all, then we would say no, this does not show direct variation. If we graph this this line right here, it would not run through the origin. As a matter of fact, you can look up here even to confirm that and see that when x is 0, y is 2. If it were direct variation, when x were 0, the y would also be 0. So that kind of just confirms that we're on the right track. Number 20, we'll do the same thing. So we'll take our y and we'll put it over our x and calculate. So this is again, we're just calculating the ratio. -2 over -3, we get 2/3. -2/3 divided by -1, I'm not going to write that out, but we know that would be positive 2/3. Over here, 2/3 divided by 1, again, 2/3. Here we set y, which is 2, over x, which is 3, 2/3, and then 10/3 divided by 5, again, will give you 2/3. So all of these, include that one in here because I had to reduce that one, all of those are the same. Because they're all the same, that means we do have direct variation. And maybe you realized it as you were doing it, but we were calculating the slope there. We were calculating the constant of variation, that 2/3. So we can then write out our direct variation equation very easily by taking that 2/3 and sticking it in there for slope, for our m value, our constant of variation in this case, and just stick our x on there. And so that's our final answer there. Okay, so let's use this idea in a couple of word problems here. The number of pages p a student can read varies directly with the amount of time t in minutes spent reading. So p, the number of pages, is going to vary with the amount of time that you're allowed to read. That makes sense. The more time you read, the more pages you're going to get read. So they vary directly. So we know p is going to vary directly with t. Okay, we're just going to write those down in that order. And if they vary directly, then that means we can come up with the constant of variation. All right, so I'm going to put an equal sign here, and I'm going to go ahead and write my m in, because we've been calling our constant of variation m. When we write it out, this is just another version of y equals mx. I'm just changing the y to p because now our y's are going to be pages, the number of pages that we read, and I'm changing x to t because it's going to represent the amount of time we spent reading. We want to know how these vary. Well, we know they vary directly, but we want to know what that constant variation is, so we're going to need to calculate m. In the very next sentence, they tell us that the student can read 90 pages. Right, so there's your p in 60 minutes. So they gave us 1 point on our graph. Right there, they gave us 60, all right, and 90. All right, so if we were going to graph this, we would already have 2 points because we know it varies directly, so it would go through 0, 0, and we have 60, 90. All right, when we calculate out m then, here we end up with 3 halves, 3 over 2. So there's our slope. We're going to stick it back into our equation, leaving our x and y, which are t and p at this in this problem. We're going to leave those open because now, so this is a direct variation equation that we can use any t with. So the last sentence says predict the number of pages a student can read if 90 minutes is spent reading. So then I'm going to evaluate at t of 90. And when you do that calculation, you end up with 135 pages. So actually, again, if we were needing to graph this, we have another point. Right there we have the point that would be 90 for our P, and I'm sorry, 135 for our P, and 90 for our T value. So we've got a third point on top of it if we were to need to graph this. All right, and then number 22 is the same. Same idea. The cost C of going to the movie varies directly with the number N of people attending. So C varies directly with N. And I'm going to stick that M in there because we're going to calculate the constant variation. The next sentence tells you that a group of 4 paid $14 to go to the movies. So they gave you your C of $14, your cost. They gave you your N, which is 4 people. Okay, so that's 1 point on this graph, 4 comma 14. And we'll get a constant of variation of 7 over 2. So I'm going to take that number and then you will evaluate in when, for that last part, how much would it cost for 7 people to go to the movies? So you would put that in for your N, put in 7 for your N, and calculate that out. And you will get $24.50.